So, hello everybody. I hope you've had a fantastic day. I know that I have. I know you've done many meetings. You've met your experts. You've met the people who have got some of the really exciting businesses from the UK. I hope you've had a chance to have a look at the innovation map, the directory, which has got some of the other things that are there, and of course enjoyed the fantastic panels that we've all seen today. So now's the time for, you've made it through to Remo, the other format, which has the peer-to-peer networking on it, and this is a virtual networking session. And I hope that you can take the opportunity to use this to network with each other, to chat about what you found out, meet some people. You just move from table to table. It's quite intuitive. Click on the table where you want to go to. No shame in leaving mid-conversation. Do feel free to. You can't use the excuse of I've got to go to get a drink from the bar, but you can just move around. That's the idea with Remo. So I'm feedback on how the day's been for you as participants, and I know the BIA team that have put this on, Sam, Georgina, Jane, Marcia have done a fantastic job. So thanks to them for holding this all together. Thank you to our participants and panelists, and for you for attending. So we are keen to get feedback as to how we can do this better in the future, and please drop us a note. And of course, on the innovation map, also keen to see how we can improve, how that can be used best. So any feedback gratefully received. We like to have a centerpiece to a Remo networking session at the BIA, and I'm delighted that to sort of close our first festival, the headline act, if you want, is a fireside chat between Mark Cotter and John Cumbers. I'm going to leave the stage now, leave the floor to them. It's fantastic to be able to do this transatlantically. One of the benefits of the virtual format is we can have people like John participate far much easier than you'd see in other places. So it's great to welcome them both. Mark and John, over to you.
Thank you, Steve. It's a pleasure to be here live in London, and the weather is even beautiful for me today. So thank you for having me. I'm just kidding. I'm actually here in the Bay Area, and when I got the invitation, I had some anxiety. I was like, oh my goodness, is somebody inviting me to London? I'm not sure I can leave my home. I'm not sure I can get on a plane. And then I started going through the brain cycles of actually, oh, you know what? I do like London. It's a great city. I could see my friends. I could see my family. So you can feel now. My wife just got her vaccine, a shot of Moderna 2 days ago. I got mine last week. So our family's now fully vaccinated, coming close behind from the UK. California's reopening in about a month or so. So very excited to be here. So thank you, Steve, and thanks to the BIA. And it's an honor to introduce Mark Cotter, not only the CEO of one company, which is BitBio, which is very exciting, we're going to be talking about, but the second company, which is Meetable as well. So I think Mark is an Elon Musk type character who can juggle two companies at once. We are going to make this a live Q&A. If you have questions that you want to ask Mark, you can type them into the box here on the right, and we'll try to fit them in. We've got only about 15 minutes or so, and then we've got some networking afterwards. So I hope you'll stay for the networking. Mark, welcome to the BIA event.
Thank you so much, John. It's a real pleasure to talk to you across the pond, so to speak. It's a very exciting event so far. I'd like to say that I'm not the CEO of Meetable. I think.
Oh, I apologize.
Kai would like that. But they're doing an incredible job, essentially using synthetic biology to create cultured meat.
But you founded Meetable, is that right? Is that what I got wrong?
Yeah, that's right. Yes, exactly. Yeah.
Got it. Okay, well, an even smarter founder then, who passes over to a professional CEO to lead things. Let's focus on BitBio. Tell us, you've been working on this idea of cellular programming now for a couple of years. So explain to people who don't know what it is. What's the core technology around BitBio? What is cell programming?
Yeah, great. So I mean, the reason why I ended up doing what I'm doing is really because I experienced on the academic side that there's a big difference between human cells and animal cells. Quite frankly, the cell that I studied, oligodendrocytes, really behave very differently. So I tried to get to a source of cells that would allow me to look at the biology of human cells. And I was in the Stem Cell Institute, recruited by Roger Peterson, and I found out at the bench how hard it is to get these pluripotent stem cells into the cell type that you actually want. And then Yamanaka happened, and then Marius Wernick published his paper, and this opened this era of cell reprogramming, which actually dates back to the 1980s. So what's cell programming? I think it's taking gene codes, and these are often transcription factors, to create new functions in a cell. And what we want to do at BIA was really to create a new cell type, a new identity. And that's pretty, so that's what.
And so it does it via the combinatorial turning on and off of transcription factors. Is that right?
Yeah. So what we learned over the past decade, I would say, is that the notion of cells being the history of a differentiation program, where you have sort of stepwise progression, it can be challenged or is challenged by what we find with Yamanaka and other reprogramming paradigms, which really just say that if you want to create a new cell identity, you need to switch on the right subcellular programs, and these are called gene regulatory networks. And you use transcription factors of doing this. So in a way, we've turned cell biology into sort of an input-output function where you activate transcription factors that jumpstarts a cascade of events, which then self-stabilize and create a new cell type, if you get it right.
So the frustration that you saw was that we were using, let's say, models that were inaccurate for human diseases. So what was the state of the art before we started using human cells to do this?
Oh yeah, so I jumped on the first human oligodendrocyte precursor cell differentiation protocol, and it took 170 days, and you had no idea whether you could actually get to the cell because all sorts of things can go wrong, and it's sort of a stepwise process, and this is true for many differentiation protocols, and so only there's been a huge effort trying to sort of make this robust and scalable. And there's been a couple of companies that have been able to do so, but it's extremely hard. Now, synthetic biology, reprogramming is this completely new paradigm, and we can, just by using this process, cut the time frame to a tenth essentially. And what we then had to figure out, because when you do this is often very inefficient, and it really depends on how you switch on the program. And this is where our core technology that we had to develop in order to get oligodendrocytes, because they're just such feisty cells, and enabled us to do so. So, and we had no idea that this would turn out to be so robust. Really. In fact, when my students first showed me the first reprogramming protocol, a neuron, they created a neuron using this OptioX approach, and I saw every cell turn into a brain cell. I couldn't believe it, and I thought they tricked me. I'm sort of fancy photoshopping, but it does work.
And what other cells have you been able to create apart from neuronal cells?
So we've really tried to go pretty broad as a proof of concept. And if you think about cells, you think about germ layers, so a bit different sort of developmental origins. And we really were able to create every germ layer. So from liver cells to brain cells to mesenchymal cells, such as muscle cells. I think in the field, it's not only us. There's many labs in the world working on reprogramming, and they're finding the same thing. This is an approach that cuts through the development.
And part of the technology that you've developed is using computational biology, machine learning to close the experimental loop. So you've got these cells, you've got transcription factors that can turn on and off different genes. You can shunt the cells that are stem cells into liver cells or heart cells or neurons. How are you using machine learning and big data to integrate that whole process?
So we're in this moment in time, although I said many people, or increasing amount of people are working on this field, we're really sort of at a blank slate. I'm taking this data from what we experienced in the Human Cell Atlas, which is a big sort of expedition similar to the Human Genome Project, and their task is to identify what cells actually are in our bodies. And there's one pattern that seems to be prevalent. Every time a Human Cell Atlas endeavor takes place, they tell us there are more subtypes than we thought about. There are more cells in the tissue, more different cells that we expected there to be, and that the world is just more complex. Now, we believe that all these different cell types, subcell types, even cell states are regulated by gene-regulated networks controlled by transcription factors. And so the question that we need to ask here is, how do we get to a particular cell type? Now, the approach that we're taking is doing this using screens. And then, of course, once you're in a screening paradigm, especially if you use high-dimensional outputs, our brains can't cope with the information. I mean, I struggle to cope. Actually, I can't really analyze even a sequencing experiment. I'm sort of picking and choosing. But I think that's the wrong approach for biology, and it's certainly the wrong approach to create new cell types. And this is where machine learning comes in. It's really an interpretation of experimental findings, and also an interpretation of the landscape.
Great. I want to remind everybody that if you have any questions for Mark, you can type them into the chat box or the Q&A box on the right. And Mark, the US ecosystem is extremely hot right now. We've seen at SynBio Beta, we've been running our global event every October for the last 9 years, and we've seen it grow from 150 people to now 1,500 people. And we've seen, just in the last month alone, we've seen multi-billion-dollar IPOs by Zymergen, and then just last week a SPAC, a $17.5 billion SPAC by Ginkgo Bioworks. Things are really, really taking off here. How is the synthetic biology ecosystem in the UK?
I'd say I think we have a very strong academic base on which we can build. There's an incredibly deep talent pool in the UK. And obviously see sort of SynBio being adopted in one or the other form across multiple, startups, companies, etc. I don't think we can compare ourselves at this point in time with what you've just described in the US. But I think as a community and as a country, we're punching above our weight.
That's great. What do you think that the UK is lacking? What do you think the ecosystem needs more of?
So one of the things that is more available in the US is, of course, the capital base. I would say that's one important thing. Maybe a bit of the boldness, especially at the early stages of companies. Maybe some of the SynBio Beta. Maybe you need to have a parachute or sort of an auxiliary event in the UK.
We would love to come back to the UK and do more ecosystem fostering. I'm curious specifically about the fundraising. How much of your capital has come from the US so far?
So in our case, it's really the overarching majority of the capital that came out from the US. I mean, we only took one European investor at the early stage. but that, I think that's actually sad. I mean, as much as I love and like all that I've described about the US investor base, I do think it would be good, and quite frankly, in the national interest, if there were a funding mechanism for these sort of news platform-based companies. So I think UK has been terrific in creating and producing new drugs, but platforms are a bit more difficult to position.
Got it. We have a question from James Peach, who says, do you feel that the value of iPSCs in drug discovery is going to be pushed forward by ability to create iPSCs better or to use them better? And maybe we've got to wrap up here in a couple of minutes. So maybe you could also use your answer to talk about what's coming next for BitBio.
So I think iPSC is a crucial technology and tool. And yes, it can address, the research and drug discovery market, of course, because the transition from preclinical to clinical is essentially a transition from non-human species to human species, and that causes enormous fallout in terms of the drugs. They just don't work the way, or they're toxic in another way. And of course, the only way of making sure that the drugs that this is de-risked is to sort of insert, I would say, the human element at this early stage. And iPSCs are key. And in terms of cell therapies, if you think about it, the bottlenecks are really the industrial scale manufacturing. We're looking at something that is very cost intensive at the moment, even though it has incredible impact. Even I'm always comparing CAR-Ts to the Brother Wright flight. It's the first time we take off, but the impact has been incredible. Now we need to sort out how we make this something that is available to everyone and at an industrial scale.
Great. I think we have time just for one more question that came in from Eric Johnson. Do you think that the big IPO valuations in the US will wake up more UK investors to the SynBio opportunity and boost investment in early SynBio companies?
I would hope so. I do think that a company like Ginkgo, for example, brings something really important to humankind. I would say it's a different perspective on biology, but it's also providing new opportunities that just weren't there. And of course, if you open up new opportunities, you should see big markets behind those new opportunities. And the good thing about that is that I think those markets are opening up, and some of them are really already existing. So I think that SynBio should be a very attractive proposition from that perspective. And if you think about what biology does, which essentially is, from a SynBio point of view, you are manipulating systems that can self-replicate and scale. Then you can see how this is also very crucial if you want to address some of the sustainability aspects that we're facing, where just old hard tech won't work, and where SynBio, so SynBiotech, can actually create a solution.
Excellent. I'm sorry we didn't get to all of the questions, but Jane and Richard, if you want to come find Mark or I in the networking now, then you're welcome to. I can stay on for another 10 minutes or so if anybody wants to connect. So Mark Cotter, the founder of BitBio and the founder of Meetable and the CEO of BitBio, thank you for joining me for this BIA Startup Festival Fireside Chat. Really appreciate it.
Thank you, John. It's been a pleasure as always, and thank you, Steve, for the opportunity as well.
Oh, thank you both. I found that really exciting. I mean, it's fantastic what's going on, and for me, John, I think we went to Ginkgo a few years ago, and to see where they are today, I mean, it definitely shows that this is where the action is at and what is going to move. And I think that the UK has been there really since the forefront, and you know, the academic network is now starting to produce, in my perspective, practical propositions that can be turned into companies, which is what's so exciting. So yeah, I think we stand a chance of surfing this wave. It's fantastic to be able to do it, and I encourage us all to quit this show and go and network around, meeting some peers and having some chat. So thank you both for setting the tone, and let's enjoy the conversation as we go forward. Thank you all.
Thanks, Steve. Good to see you again.
Thank you.